Okay, guys, we're going to talk about meiosis today, and it's looking like it's exactly like mitosis, and it's not. So let's see how meiosis differs from mitosis, and let's talk about drawing. Because as you know, I'm all about drawings, and I think drawing is a really good way to learn your different meiosis, mitosis. And so we'll start with meiosis 1. We'll do meiosis 2 in a minute, but we start meiosis 1. We have a cell that is 2n equal 4. So you have homologous pairs, and 2n equal 4 means you have 4 chromosomes that are replicated in this case, because we start by prophase, and prophase is post-interphase, and interphase is where DNA replication takes place in S phase. So we had the G0, G1, S phase, we replicated the DNA. Then we did G2 to prep for meiosis, and now we start meiosis. And so prophase, when it's meiosis 1, is called prophase 1. Prophase is a step, and I'm going to make all the membranes is in green. It's a step at which you have a cell membrane, and inside you have your nuclear envelope with the pores, remember? We also have the centromeres. Sorry, the centrosomes. The centromeres are on the chromosomes. The centrosomes are here, and the spindle fibers start forming. So I want us to realize that prophase 1, it's really similar to the prophase from mitosis. 3 things happen. The centrosomes with the spindle fibers are forming. The nuclear envelope is dissipating, disappearing. So it's not just nuclear pore now, the entire envelope is disappearing. Inside of that, your chromosomes are still in there, so they start, that's the third thing that happens, they start condensing. So instead of having that wall that is like all kind of messy, you start having a clear vision of chromosomes. And since we have 2n equal 4, we have 2 pairs of chromosomes, which makes 4 chromosomes totals. And they are replicated, those chromosomes. Okay, so that is the first phase of meiosis, my bad. Meiosis. The second phase of meiosis is metaphase. And in metaphase, and once again, it's metaphase 1. In metaphase 1, what we see in our cell is all of the chromosomes aligning in the middle. So if you remember in mitosis, the alignment was all of the chromosome in one plane, because the game at the anaphase was to separate the sister chromatids, right? In meiosis, the sister chromatids are not separated in meiosis 1. The homologous chromosomes are separated. So what aligns in the plane in the middle, those are the homologous chromosomes, and they put themselves on either side. So you will have one of the big guy here and the other big guy here. And then the small guy and the other small guy. Why do they align in the middle for, and compared to what? Compared to the centrosomes. Remember the centrosomes? Now they have a maybe should keep the same coloration going on. That would be great. So red for the centrosomes and the spindle fibers. So the centrosome are on either side of a cell, and the spindle fibers are attaching at the centromeres of the chromosome. But notice how the difference. In meiosis, they attach to one of the homologous pair only, because it's going to pull those homologous pairs apart. Remember, metaphase 1 is prepping for anaphase 1, so meiosis 1 is about separation of the homologous chromosomes. Mitosis, all of those would be aligned in one line in the middle, and you will separate the sister chromatids, which you don't here. So the spindle fibers reach the centromere of only one of the pair per side. So that side takes one of each pair, and that side takes one of each pair. that leads the way for the next step, anaphase 1. Anaphase 1 is the separation of the homologous chromosomes. Now your cell is elongated. Now I turned it around. So those are the centrosomes, right? And each one of the pair of chromosomes is pulled apart on either side. And so in that case, once again, the legs are lagging behind from the attachment point. Right? But the legs are lagging behind from the attachment point. That's the spindle fiber coming from the centrosomes. Right? And it's pulling them apart. So you separate the homologous chromosomes, right? You separate the homologous chromosome. This is anaphase 1. And then the last of the phases, you go to telophase 1. And then you have plus cytokinesis here. Because we're still in meiosis, we're going to go to meiosis 2. But the first step of meiosis, at the end of meiosis 1, is telophase 1, followed by cytokinesis. So now you get the cell to be split. And so now you get the plate at the middle. If you're a cell from from a plant, if you're an animal cell, you still see the squeezing in the middle, the cell dividing in two, and as you would in a normal mitosis, you get at the end of mitosis with cytokinesis, you get a new nuclear envelope reforming. So that telophase 1 is pretty much similar to that telophase from mitosis, where you see reforming of the nuclear envelope. You see the chromosomes being inside there, and there's one little and one big on each. Right? And now you have separated the homologous chromosome. Of course, the centrosomes are in there, and they start their next step, which is doubling again. And so now you're done with meiosis 1. So really, meiosis 1, it's all about division, separation of homologous chromosome. Several little points to remember. Different crossing over can take place. It would be during prophase 1 for crossing over. You can have problems that take place during the separation of homologous chromosomes in anaphase 1. We'll talk about it in another video when you have non-disjunction. So imagine instead of having one of each pair going on either side, you have two of one pair going one side. So now you have 3 chromosomes here and 1 there. So that's a problem that can lead to trisomy 21, 23, and all. That's the crossing over. We'll talk about it in another video, but that's when it can take place. Okay, let me pause here and erase the board and do meiosis. Okay, and we're back. For meiosis 2, I am not going to do like the 2 daughter cells. You remember at the end of meiosis 1, you have cytokinesis. You went from 1 parent cell to 2 daughter cells with 2 different sets of each of the homologous chromosomes. I am not going to follow both of them since the same thing happens to both of them. You can see that in the PowerPoint. I'm just going to follow one at a time, like only one. So I'm going to focus on one of the 2 cells coming out of meiosis 1. So you start meiosis 2 with that 1 cell, right? And so the first step of meiosis 2 is, sorry, prophase 2. It's really, really clever. In prophase 2, exactly the same thing at prophase 1 or mitosis prophase. You have the nuclear envelope that has, in our case, do remember that we have only 1 chromosome replicated though of each pair. We don't have 2. They're already condensed. the first thing that happens is the nuclear envelope disappears. And so it's disappearing, the nuclear envelope. That's prophase 2, and the spindle fibers come out of the centrosomes. Once again, they are synthesized. And the centrosome, remember that we have only one that went that way, so another one has been synthesized as well. So that's prophase 1. Really simple, really easy. Just get your nuclear envelope to go away once again. Get your spindle fibers going, and your chromosome being already condensed. Now you switch to metaphase 2, and metaphase 2 is really, really similar to mitosis metaphase. The reason for that is, in this case, meiosis 2, it's all about the separation, the segregation of sister chromatid. And yes, here we will separate the sister chromatid. So what happens is those chromosomes, they then align all of them in the middle of the cell. So remember, we work with a cell of 2 and equal 4, so we have only 2 chromosomes in that case. In meiosis 2, we divided already by half. And why do they align in the middle, you may ask? Because the centrosomes on either side with the spindle fibers attach on either side of those chromosomes. So compare this step here, metaphase 2 to metaphase 1. Notice how spindle fibers from either side attach to the same centromeres. Because now you're going to separate the sister chromatids. The sister chromatids is each leg of the chromosome, each chromosome copy of DNA. Because those chromosomes are replicated, they have 2 copies of DNA. The metaphase 1, we separated the homologous chromosomes. Those spindle fibers were attached only to one of the pair of homologous chromosomes. We separated those in meiosis 1. Metaphase 2 now, the spindle fibers attach on the centromeres of each chromosomes on either side. That's getting ready for anaphase 2. In anaphase 2 is the segregation of sister chromatid. We stay clever, we get the names straight from the name of the step, the process in which we are. So once again, I flip things around, and in anaphase 2, we get the separation, segregation of sister chromatids. So here we go, centrosomes here, and they pull those sister chromatids apart, which means that if you pull, the legs are falling, dragging behind, right, when you pull, because the centromere is pulled apart. So we broke the attachment from those 2 molecules of DNA. Those were together, and when you pull them apart, remember, it's like putting a bungee cord around my waist. They're pulling really hard. I want to have my legs and arm pulled and dragged behind me while my waist is going towards the person pulling me. So this is segregation of sister chromatids. That's the really important step of the meiosis 2. And we finish on meiosis 2 with a regular shebang of telophase 2, and that will follow by finishing cytokinesis. And in telophase 2, although we see a start of a pinch maybe forming, if we really want to be Mr. Mystic Stickler. But more importantly, remember, telophase is the inverse of prophase, and telophase 2 is no exception. In those cases, you now have the nuclear envelopes reforming around the packs of chromosomes. And in that case, we now have one long leg and one short leg, one from each pair. And now our cell went from 2n equal 4 to n equal 2. Now, let me pull right up for you to see it. Now we have n equal 2, or maybe I should just, yeah, let me just write it here, n equal 2. And the centrosomes and spindle fibers are resolving. Remember, it's the opposite of prophase 2. And here you go. That's meiosis 2, separation, segregation of sister chromatids. It's in anaphase 2. So once again, you can have issues. You can have in anaphase 2 non-disjunction. So imagine those don't separate. So now on that side you have double chromosome replicated and unreplicated chromosome, whereas here you have only one. So you end up having at the end here issues when you do the cytokinesis. Instead of having haploid cells, you have semi-haploid, because some of them will have 3 copies. So that's another key here. We went from diploid cells, and at the end of cytokinesis, we have 4 haploid cells that all have only 1 molecule of DNA from each pair of homologous chromosomes. So meiosis 1, separation of homologous chromosomes. Meiosis 2, segregation of sister chromatids. Really important to remember that. In that case here, crossing over is not present. It's really in prophase 1 that you see crossing over, because you already separated the homologous chromosomes, so you don't have homologous chromosome together anymore. Okay, that's it for meiosis. It's a little bit of a long video. It's getting to 17 minutes. Hopefully you can do that drawing on your own several times, as long as until you get it and you're able to draw it on your own. And when you're done with that, you're able to draw it and turn it in. We'll have a drawing due this week. But really, I encourage you to draw and draw and draw, and remember when can happen non-disjunction, anaphase 1, anaphase 2, why, what's happening, what is the difference between metaphase 1, metaphase 2, and the mitosis metaphase. What's the difference between prophase and telophase? What are the similarities? Make sure you understand the process for meiosis 1, separation of homologous chromosome, compared to meiosis 2, segregation of sister chromatids. And that's all for me. You guys take care.